Let's start with a scene today that feels, well, it feels like it's pulled straight out of a psychological thriller. But it's actually just 1960s South San Francisco.
Yeah, completely normal setting.
Yeah.
You walk into a standard elementary school, linoleum floors, that distinct smell of chalk dust, the whole 9 yards.
Exactly. It's the beginning of the school year, and all the first and second graders are being marched into the cafeteria to take this test.
Right, and this wasn't just your standard spelling bee or a math quiz. The teachers were told this was the Harvard test of inflected acquisition.
Which, I mean, just the name alone sounds incredibly intimidating. It sounds like something that's going to measure your very soul.
It was absolutely designed to sound that way. The researchers, Robert Rosenthal from Harvard and the school principal, Lenore Jacobson, they told the teachers that this specific test had the power to identify what they called bloomers.
Blimmer.
Yeah, bloomers. These were supposedly kids who were on the verge of a massive intellectual growth spurt. They essentially said, look, these kids might seem average right now, but biologically they are just about to take off.
So the teachers administer the test, right? And the papers get sent away to Harvard or wherever they supposedly went. And then a few weeks later, the results come back. The researchers hand the teachers a list of names and say, here are your bloomers. Watch these kids. They are special.
But here is the massive deception. The test was completely fake.
Well, fake in what it measured, right?
Exactly. It was a real standard IQ test, the 2GA, but it didn't predict blooming at all. It just measured current IQ. And the names on that list, Rosenthal had chosen them completely at random. He literally pulled names out of a hat.
Meaning there was zero biological difference between the bloomers and the control group.
None whatsoever, just random chance.
But the teachers didn't know that. They thought they had the next generation of Einsteins sitting in their classrooms. So they go through the school year, they teach, they grade, they interact. And then at the end of the year, Rosenthal comes back and retests everyone with the exact same IQ test. And this is where the story gets really unnerving.
It does, because the bloomers, the kids chosen purely at random, they actually bloomed. Their IQ scores rose significantly more than the other children's scores did.
And we aren't talking about some tiny margin of error here, are we?
No, especially in the first and second grades, the statistical difference was huge.
So let's just pause on that for a second. Because the kids themselves didn't change. The only thing that changed was the idea planted in the teacher's head.
Right, because the teacher believed the child had this innate genetic potential just waiting to happen. They treated them differently.
Maybe they smiled more when the kid walked in. Or maybe when a bloomer got a question wrong, the teacher thought, oh, they just need a moment to figure it out. Whereas if a regular kid got it wrong, they thought, well, they just don't get it.
Rosenthal called it the Pygmalion effect. It's a classic self-fulfilling prophecy. But for our purposes in this deep dive today, it illustrates a mechanism called a looping effect.
A looping effect.
Yeah, the classification itself, the label of being a bloomer, actually shaped the human subject it was supposedly just describing.
And that looping effect is the absolute perfect entry point for the source material we are unpacking today. We're doing a deep dive into the book What We Inherit by Sam Trejo and Daphne O. Marchenko.
Which is a fantastic read.
It really is. And ostensibly, this book is about the cutting edge of the DNA revolution. We're talking about things like polygenic scores, embryo selection, big data, but fundamentally, it's really about that bloomer dynamic you just described.
Exactly. It's about how our social beliefs about biology can be just as powerful and, frankly, just as dangerous as the biology itself.
What I really love about the sources we have today is that the book refuses to just sit comfortably in one camp. You know, usually when you read about genetics, you get one of two extremes.
Oh, absolutely. You either get the, hooray, science is going to save us all, we're going to gene edit our way to a perfect utopia book.
Or you get, the Gattaca is already here, pure dystopian warning book. But this book is actively trying to hold both of those realities in the same time.
And that is largely due to the authors themselves. They're a bit of an odd couple.
Odd couple is putting it mildly. Academically speaking, they are practically chemically reactive. You have Sam Trejo, who is a quantitative sociologist.
Right, he's the data guy. He lives in spreadsheets, utilizing these massive genomic data sets to try and understand really complex social outcomes, things like education levels, income, poverty. He believes fundamentally that this data is useful and necessary.
And then on the other side, you have Daphne O. Marchenko.
Yes, and she is a bioethicist.
Yeah.
A qualitative researcher. She deals in narratives, in history, in the social fallout of scientific advancement. She's the one constantly pointing at the dark history of eugenics and saying, hey, do we remember the last time we started ranking people by their biological potential? Because it did not end well.
In a typical university setting, these two would be in completely different buildings. They'd probably be ignoring each other entirely, or maybe writing passive-aggressive journal articles debunking each other's work.
That's the usual academic model. But they decided to do something different. They engaged in what they call adversarial collaboration.
Which is a concept popularized by Daniel Kahneman,
It
right?
is. The core idea is that if you disagree with someone fundamentally, you don't just debate them from across the room. You work with them. You try to co-author a paper, or in this case an entire book, that you both can actually sign your names to.
I mean, that sounds miserable, honestly. Imagine trying to write a book with someone who disagrees with your most basic premises.
It sounds totally exhausting. But the result is that they manage to bridge what they call the murky middle. They simply don't let each other get away with lazy arguments.
Right, Sam can't just wave away the history of scientific racism, because Daphne is sitting right there to check him.
And Daphne can't just dismiss the predictive power of the genomic data because Sam has the scatter plot sitting on the table to prove that it actually works.
And out of all this friction, they develop the core framework of the book, the structural metaphor for our entire deep dive today. They call it the two acids.
It's a brilliant way to frame it. You have the literal acid and you have the conceptual acid.
So the literal acid is DNA itself, deoxyribonucleic acid. The actual chemical reality, adenine, thymine, cytosine, guanine, the sticky physical stuff inside the test tube.
Exactly. That stuff exists. It does things. It builds proteins. It influences our height, our hair color, our baseline risk for developing diabetes. That is the undeniable biological reality.
But then you have the conceptual acid, and this is the idea of DNA. It's the cultural baggage, the myths, the narratives we inherit and tell ourselves about what genes actually mean. It's that Bloomer label we talked about earlier.
And the authors make the case that the conceptual acid is often way more corrosive than the literal one. Think about it. When you tell someone, oh, it's just in your genes, that sentence carries a massive psychological weight. That saying, it's in your environment, just doesn't have.
We treat genes as destiny. We treat them as these completely immutable fate markers.
We do. So the mission of this deep dive today is to really explore what happens when these two acids mix. Because we are living in a moment where the literal acid is becoming incredibly high-tech.
Right, we have massive biobanks and wildly complex predictive algorithms now.
But our conceptual acid is still basically stuck in the 19th century. We're wielding these space-age tools, but we're interpreting the results through Stone Age biases.
And that collision is exactly where the danger lies. So let's jump into the first major section of our discussion today, which explores what the book calls myths of the blood. Because before we can even begin to understand the futuristic tech, we have to understand the old stories we're projecting onto it.
And the authors start this section with a visual that is just, it really breaks your brain a little bit if you rely on standard societal racial categories. They tell the story of the Biggs twins.
The Biggs twins, Millie Marcia Biggs and Marcia Millie Biggs, born in England in 2006. Walk us through their story, because the visual aspect is the whole point here.
Right, so their parents are a mixed-race couple. The mother, Amanda, is white. The father, Michael, is black, of Jamaican descent. They have these non-identical twin girls.
Fraternal twins.
Exactly. And when the girls are born, they look pretty similar to each other. But as they grow up, their appearances diverge radically. Marcia develops pale skin, blue eyes, and blondish hair. She presents to the world as white. Millie, on the other hand, develops dark skin, brown eyes, and tight curly hair. She presents to the world as black.
They were actually on the cover of National Geographic a few years back, and if you look at them side by side wearing the exact same clothes, it just forces you to confront how totally arbitrary our social categories really are.
It really does. And the book focuses heavily on the mother's explanation for this. When people inevitably ask Amanda how this is even possible, she just says, well, it's genes.
Which, to be fair, is true.
It is technically true. They are non-identical twins. Biologically, they are essentially just siblings who happen to be born at the exact same time. It's a genetic shuffle. One happened to get the pigment genes, and the other one didn't.
But the authors argue that saying it's genes is actually a trap.
It is a trap because it implicitly suggests that the racial category itself is genetic.
Right. We look at them and society says one is black and one is white. But biologically speaking, they are sisters with the exact same ancestry.
Exactly. And this leads us straight into the first big myth they debunk. the destiny myth, or what scientists call genetic determinism.
Which is the idea that your DNA is a rigid blueprint. You are the building, and you absolutely cannot change the layout once the concrete has been poured.
Right. And to trace the origins of this, we have to talk about Francis Galton. You really can't talk about genetic determinism without talking about Galton.
Darwin's half-cousin.
That's the one.
Ah.
He was a brilliant statistician in many ways, but he was also the father of eugenics. And he had some deeply, deeply flawed ideas about how human society actually works. In 1869, he published a book called Hereditary Genius.
And his basic methodology was to look at rich, highly successful men and say, wow, look at this. Their sons are also rich and successful. It must be in the blood.
That was literally his entire thesis. He constructed these elaborate pedigrees of judges, statesmen, scientists. He observed that societal success ran in families, but he completely and utterly ignored the environmental transmission of status.
Right. If you are the Lord Chief Justice of England, your son is going to go to the absolute best schools, he's going to meet all the right people, and he has a massive financial safety net.
Exactly. Galton looked at all that obvious social advantage and saw only biology. In fact, he is the one who coined the phrase nature versus nurture, which the authors argue is one of the most damaging dichotomies in the history of science.
Because it sets them up as enemies. It implies it has to be either nature or nurture. It's a zero-sum game.
And Galton was firmly planted on Team Nature. He famously believed that nature prevails enormously over nurture. And the alarming thing is that this isn't just dusty Victorian history. This way of thinking is still very much alive today.
The authors actually point to Donald Trump as a modern example of this Galtonian mindset, specifically what has been called the racehorse theory of human development.
Right. Without getting into the politics of it, the book impartially notes that Trump has been recorded multiple times explaining his view on human success by comparing it to breeding racehorses.
He talks about having the right genes or telling crowds that they have good genes.
Yes, and the underlying implication of that rhetoric is that success, whether that's money, power, or fame, is an innate biological trait, just like having blue eyes or being tall.
And it's a very comforting myth if you happen to be the one who is successful, right? Because it means you inherently deserve it. Your success is cellular. It's not just luck or the inheritance of wealth. It's the inheritance of pure merit.
And conversely, if you are poor, well, that's just nature taking its course. You can't fight nature. It's a framework that perfectly justifies existing social hierarchies.
Which bleeds right into the second major myth they tackle, which is the race myth. And we need to be very precise here because people get incredibly confused about the difference between race and ancestry.
This might be the most critical distinction in the entire book. Ancestry is biological, is the literal record of who your parents were and their parents, stretching back through time.
The family tree.
The family tree.
Okay.
We are all related if you go back far enough, but we do have clusters of ancestors who lived in specific geographic regions. That is the literal asset. That's real.
Race, on the other hand, is the conceptual asset.
Exactly. Race is the social box that we decide to draw around certain clusters of physical traits, and the boundaries of those boxes change depending on where you are geographically and when you are historically.
To illustrate how this race myth gets weaponized legally, the book uses the famous case of Loving v. Virginia.
1958. Richard and Mildred Loving. They were an interracial couple who were arrested essentially for the crime of being married. He was white and she was Black and Native American.
And the trial judge in that case, Leon Bazile, he issued an opinion that the authors highlight as a perfect, terrifying distillation of the race myth.
I actually have the quote right here. The judge wrote, "Almighty God created the races white, black, yellow, Malay, and red, and he placed them on separate continents. The fact that he separated the races shows that he did not intend for the races to mix."
It's just staggering to hear that read out loud. He is claiming that these purely social categories are divinely ordained, discrete biological species.
He's making a massive category error.
Yeah.
He's mistaking a social law that humans invented for a natural law of biology.
But my absolute favorite example in the book of how fluid these categories really are is the story of Harry Murphy. It perfectly exposes the absurdity of biological race.
Oh, Harry Murphy is the ultimate real-world rebuttal to that judge's logic. So Harry Murphy lived in the U.S. in the mid-20th century. He had some African ancestry. And under the one-drop rule, which was very prevalent in the South and many other states at the time, he was legally categorized as Black.
But then he moved to California.
He moved to California, and California simply had different state laws about how racial categories were defined. They didn't strictly apply the one-drop rule in the same way. So Legally speaking, the moment Harry Murphy crossed the state line into California, he became white.
His biology didn't change. The literal acid in his cells was exactly the same in California as it was before he moved. But the conceptual acid, the label society applied to him, completely flipped.
And you have to remember, that label dictated where he was allowed to live, who he was legally allowed to marry, and what kind of jobs he could get. So when researchers today talk about racial differences in health outcomes or wealth generation, the big question is, are we measuring the effect of the DNA? Or are we measuring the downstream effects of the label black or white in a highly specific society?
And that question is the perfect segue into the second major section of the deep dive, the science of what if. Because Trejo and Marchenko argue that for a long time, we have been doing the science of genetics completely wrong.
We've been looking for the gene for X without ever asking about the environmental context that X exists in.
This brings us to what they call the counterfactual framework. And I know this can get a little heady, but it is the absolute key to understanding modern genomics. So walk us through it. What is the counterfactual?
The simplest way to think about it is this. To confidently say that A causes B, you have to be able to imagine a world where A did not happen, but every single other thing remained exactly the same. That imaginary scenario is the counterfactual.
It's essentially the parallel universe test.
Right. Let's use the example from the book involving Sam, one of the authors. He moved from Texas to California for graduate school. Let's say he is much happier now. Did the move to California cause that happiness?
To know for sure, you'd have to observe the counterfactual Sam, the Sam in the parallel universe who decided to stay in Texas, but is otherwise identical in every way.
Which obviously we can't do. We don't have access to the multiverse.
Sadly, no.
So that is what statisticians call the fundamental problem of causal inference. Because we can't observe the parallel universe, science uses tricks like randomized control trials or natural experiments to try and approximate that alternate reality as closely as possible.
Okay, so how does this parallel universe concept apply to DNA?
Well, let's look at something controversial, like the so-called education gene. We know through massive studies that there are genetic variants statistically associated with staying in school longer. If you have a specific combination of these variants, you are statistically more likely to end up getting a PhD.
So someone operating under the destiny myth would look at that and say, aha, those people are just innately smarter, their brains are biologically superior. Case closed.
But if you apply the counterfactual framework, you have to ask a different question. You have to imagine a parallel universe where those exact same people have the exact same DNA, but the social education system they live in is completely different.
The book uses a really striking example about skin color to illustrate this point perfectly.
It does. It's a very clear way to understand what scientists mean by environmentally mediated effects. So there are genes that code for melanin production. Let's just call them dark skin genes for simplicity. In the United States, having those specific genes is statistically correlated with earning lower wages over a lifetime.
And a naive geneticist from 100 years ago might look at that correlation and say, oh, look at the data. These genes must be linked to lower cognitive ability or a lack of drive or some internal flaw.
But the counterfactual framework demands that we ask, if we took this exact person with these exact melanin genes and we put them in a parallel universe society that has zero history of racism or colorism, would those genes still correlate with lower wages?
Almost certainly not.
Right. So the causal effect of that gene isn't biological in the direct way we usually assume. It is environmentally mediated. The gene produces a physical phenotype, which is skin color. Then the environment, the racism in society, reacts to that phenotype to produce the final outcome, which is the lower wage.
I want to make sure I'm totally grasping this. The gene is still technically a cause, because without the gene, you wouldn't have the darker skin color. And without the darker skin color, you wouldn't experience the societal racism. So the gene is undeniably a step in the causal chain.
Yes. The gene pulls the trigger, so to speak. But society is the one that loaded the gun. And understanding that distinction changes absolutely everything about how we view genetics. Because if an outcome is environmentally mediated, you don't go in and try to fix the gene, you have to fix the environment.
That reframing just blows up the entire nature versus nurture debate. It basically says that nature only really acts through nurture. They aren't opposed, they are entirely entangled.
Exactly. And the authors stress that for complex social traits, things like educational attainment, likelihood of committing a crime, income level, almost all of the genetic effects we observe are environmentally mediated to some degree.
But here is the massive tension in the book. We understand all this nuance now, theoretically. We get that it's highly entangled and complicated, but the technology is rapidly moving in a direction that practically strips all of that nuance away. We are entering the era of big data genetics.
The era of the polygenic score.
Let's talk about the tech. This is segment 3 of our dive. Because I think a lot of people still conceptualize genetics based on Gregor Mendel and his pea plants from high school biology.
And honestly, high school biology has done us a huge disservice here. We all learned about monogenic traits. Mono meaning one. One gene equals one trait. You either have the specific gene for cystic fibrosis or you don't. You have the gene for Huntington's disease or you don't. It's a binary switch.
But most things that make us who we are aren't like that at all.
No, not even close. Height, intelligence, personality traits, your risk for developing schizophrenia. These are polygenic, poly meaning many. They're influenced by thousands, maybe even millions, of tiny little genetic variants scattered across your genome, which are called SNPs, single nucleotide polymorphisms.
And if you just look at one of those SNPs individually, it's basically worthless as a predictor, right?
Absolutely worthless. If I find one single SNP in your DNA that is correlated with being tall, it might increase your predicted height by like 1 millimeter. It tells me absolutely nothing useful about how tall you'll actually be. But if I have the computing power to measure 1 million of those SNPs all at once and mathematically sum them up,
Then you get a polygenic score.
you get a single number that aggregates all those millions of tiny microscopic effects. And the rise of this specific technology over the last 2 decades has been absolutely meteoric. The book has this chart, figure 1 in the text, that I really wish our listeners could see. It shows the predictive power of these polygenic scores for years of education over time.
Describe the curve of that chart for us.
So if you look at the data from 2004, the scatter plot is just a giant cloud.
Yeah.
It's pure random noise. You couldn't predict a person's education from their DNA at all. Then you move to 2013 with much larger sample sizes, and you start to see a very faint slope.
The signal is starting to emerge from the noise.
Exactly. By 2018, that slope is getting really tight. And by 2022, the polygenic score for educational attainment is now just as accurately predictive of how many years of school you'll finish as knowing your parents' income or education level.
That is just wild to think about. You're saying that just by having me spit in a plastic tube, an algorithm can predict if I'll graduate college with the same accuracy as knowing if I grew up rich or poor.
Yes. The statistical power is undeniable at this point, and that's exactly where the two acids violently collide, because we now have this literal acid, this polygenic score, which is a statistically powerful, mathematically real number. But we risk immediately applying the conceptual acid to it, the destiny myth, and assuming that because a computer can predict it, the outcome is biologically inevitable.
Right, and because it's presented as a score, it feels deeply objective. It's a hard number on a page. It feels like getting a credit score, but for your underlying biology.
But we have to remember the counterfactual framework we just discussed.
Yeah.
That polygenic score is predicting your educational success within this highly specific society. It's capturing your cognitive genes, sure, but it's also capturing your ability to sit perfectly still in a rigid classroom genes. It's capturing your looking like what a teacher expects a smart kid to look like genes. It is an incredibly dirty number.
It's just a correlation machine. The algorithm doesn't actually know why you graduated college. It just knows that you happen to share DNA patterns with other people who typically graduate college.
Precisely. It's blind to the environmental mechanisms. And yet, we are now taking that dirty, complicated, socially entangled number, and we're starting to use it to literally design the next generation.
Which brings us to segment 4, the rise of embryo selection. This is where the whole thing shifts from theoretical sociology to actual sci-fi becoming reality.
Right, and we have to make a very clear distinction between 2 different technologies here, otherwise people get the ethics very confused. We are not talking about CRISPR.
CRISPR being gene editing, that's taking the DNA code and actively cutting and pasting it to create something new.
Exactly. That is what the scientist He Jiankui did in China a few years ago with the so-called CRISPR babies, Nana and Lulu. He edited their embryos, and he went to prison for that. Gene editing for reproduction is largely illegal globally and considered highly taboo. What we're talking about today is PGTP, pre-implantation genetic testing for polygenic traits.
And this process is built entirely on top of standard IVF, in vitro fertilization.
Yes. So in standard IVF, doctors often create multiple embryos in the lab. Traditionally, they used a process called PGTM. The M stands for monogenic, to screen those embryos for fatal single-gene diseases. Like, this embryo has the gene for Tay-Sachs, this one doesn't. So we implant the healthy one. And ethically, almost everyone agrees that is a clear medical good.
But PGTP takes those complex polygenic scores we just talked about, the ones for height or educational attainment or diabetes risk, and essentially assigns a scorecard to every single embryo in the dish.
Right. So imagine the doctor sits down with the parents and says, okay, we have 5 viable embryos. Embryo A has a predicted height in the 90th percentile and an above-average predicted IQ score. But it also shows a higher genetic risk for breast cancer. Embryo B is predicted to be average height, average IQ, but has a very low cancer risk.
And then the parents just...
The parents pick. Now, technically, this is selection, not genetic engineering or state-mandated eugenics. You are only choosing from the genetic options that you and your partner naturally produced. But it is undeniably a form of consumer eugenics.
The book actually introduces us to a real couple doing this, the Collins family, Simone and Malcolm Collins. And they are, well, intense is the word that comes to mind.
Intense is a good word. They are the founders of the Pronatalist Foundation. They have this philosophy that smart, culturally aligned people need to start having massive amounts of kids to basically save human civilization from collapse. And they are absolutely walking the walk.
And they did this embryo selection totally DIY, didn't they?
They did, which is fascinating. At the time they were doing IVF, clinics weren't offering polygenic IQ screening openly because of the ethical concerns. So the Collins demanded the raw, uninterpreted genetic data for their embryos, downloaded the massive text files, and used third-party tools like self-decode to generate the scores themselves. They literally built a spreadsheet to rank their unborn children.
And it's important to note their goal isn't just about having healthy kids. They have a direct quote in the book where they say they want their genetic line to colonize the stars.
Yeah, it's a deeply transhumanist vision. They view the human genome not as a given, but as a platform for optimization. And look, it's very easy to judge them as extremists. But if I told you, hey, you're doing IVF anyway, and you can pick the embryo that has a 20% lower risk of getting heart disease in their 50s, would you really say no?
That is the insidious hook, isn't it? It always starts with basic health. Don't you want the best possible health for your child? But then that logic slowly creeps into, well, don't you want them to be smart? Don't you want them to be tall? Don't you want them to have a low risk of depression?
And this brings us to what the authors call the portability problem. This is the massive technical flaw in the whole system that turns this from a philosophical debate into an immediate racial justice issue.
They also refer to it as the white data problem, right?
Exactly. To build a reliable polygenic score, you need a staggering amount of data. You need hundreds of thousands of people to give you their DNA, and you need to track their life outcomes. Most of this data currently comes from massive biobanks in the UK and Northern Europe.
So the algorithms that generate these scores are basically exclusively trained on white people.
Overwhelmingly so. Something like 80 to 90% of all genome-wide association study data comes from people of European ancestry.
So play that out. What happens if a Black couple or a Hispanic couple goes to a clinic and tries to use PGTP to select an embryo?
It just doesn't work.
Yeah.
Or, more accurately, it works very, very poorly. The prediction accuracy of the score just falls off a cliff if your ancestry doesn't match the training data.
And why is that? Is it because the genes are totally different?
Not the genes themselves, we all have the same genes. But the linkage patterns between the tiny SNPs are different in different populations.
Yeah.
So a specific SNP that acts as a reliable flag for high height in a British population might not flag height at all in a Yoruba population from Nigeria. The algorithm is looking for the wrong clues.
So we have this cutting-edge technology that theoretically offers massive biological advantages to the next generation. Better baseline health, maybe higher cognitive advantages, but it literally only works well for people of European ancestry.
And on top of that, it is incredibly expensive. IVF itself is tens of thousands of dollars.
Yeah.
So this technology only works for rich people of European ancestry.
We are quite literally building a machine that biologically widens the social gap.
That is the ultimate nightmare scenario outlined in the book. You take existing social inequality, which is already devastating, and you use technology to bake it directly into the biology of the next generation. You risk creating a literal caste system where the elites are not just wealthier, but they are genetically healthier and biologically optimized, while everyone else is left behind.
Which leads us perfectly into the core conflict of the book. Segment 5, the inequality debate. Because this is where Sam and Daphne, our two authors, really throw down. This is the structural versus the individual debate.
It's the absolute heart of their adversarial collaboration. It's where the tension really peaks.
So Sam, the quantitative sociologist, he looks at all this and says, look, we shouldn't throw the baby out with the bathwater here.
Right, Sam is a pragmatist. His argument is that inequality is real and it's hurting people right now. If these genetic scores can help us intervene, we have a moral obligation to use them. For example, what if we can use a polygenic score to identify a child with a very high genetic risk for dyslexia right at birth?
We wouldn't have to wait for them to fail a reading test in second grade.
Exactly. We could intervene immediately. We could provide specialized reading support and resources before they ever experience the trauma of falling behind. He sees the polygenic score as an incredibly powerful diagnostic tool.
He argues that ignoring the genetic data is actually what causes harm. Because if we pretend genes don't matter, we end up blaming the kid for failing. We say, oh, you just didn't work hard enough, you aren't applying yourself. Whereas if we know they have a genetic hurdle, we can compassionately help them jump it.
It's a very compelling argument. But Daphne, the bioethicist, is absolutely not buying it.
No, she pushes back hard. She argues that this approach leads to what she calls the medicalization of poverty. She says we already know why kids are failing in school. It's poverty, it's lead paint in the walls, it's massively underfunded public school systems. We do not need a multi-million-dollar DNA test to tell us that a kid sitting in a crumbling classroom is at risk of poor educational outcomes.
She coins this brilliant phrase for it. She calls it the datafication of injustice.
The datafication of injustice. What does she mean by that exactly?
It means we use these incredibly advanced, expensive data tools to basically just admire the problem. We map the inequality, we score it, we predict it with 99% algorithmic accuracy. But we don't actually fix it. We spend millions of dollars on genomic research to find the education genes while we're spending pennies on free school lunches.
And she has a deeper fear, too. She worries that this intense focus on genetic data validates the worldview of people like Charles Murray.
Ah, yes. The bell curve.
Yeah.
That book was a massive controversy in the 90s. Murray essentially argued that social inequality was inevitable because it was based on IQ, which he claimed was entirely genetic and immutable by the environment. The scientific community largely agreed he was wrong. The data did not support his conclusions then.
But Daphne's fear is that unregulated PGTP could actually make him right in the future.
Exactly. Think about it. If the wealthiest people in society use embryo selection to artificially boost the IQ and health of their children for 5 or 6 generations, and the poor are completely locked out of that technology, you might actually create the biological class divide that Murray only fantasized about. You could essentially engineer the racist premises of the bell curve into biological reality.
That is it's a staggeringly dark thought. But before we get to that kind of species-level, generations-long dystopia, we have to deal with the cheap, tacky dystopia that is happening on our smartphones right now. Which brings us to segment 6, the Wild West of direct consumer testing.
Welcome to the loophole economy.
So we all know the big players like 23andMe or Ancestry, but the authors dive into a much wilder, less regulated frontier. These are the wellness apps.
Right. And here's how the loophole works. The FDA regulates medical devices. If a company comes out and says, this genetic test diagnoses breast cancer, the FDA steps in and says, halt, you have to show us the clinical data to prove that. But if a company just says, hey, this test is for educational purposes, or it helps you understand your wellness or your dating compatibility,
then it's just treated as entertainment. It's basically astrology, but wrapped in a shiny veneer of big data science.
Exactly. And the book mentions a real app that was briefly available on the market called How Gay Are You?
Which is just, It's offensive on so many different levels. But explain the supposed science behind how an app like that even existed.
So it was based on a real peer-reviewed study, a massive genome-wide association study on sexual behavior. The scientists who ran that study did find some genetic correlations with same-sex behavior, but they heavily emphasized that the effects were incredibly tiny, highly complex, and completely useless for predicting an individual's sexuality.
But the app developers just ignored all those caveats.
Totally ignored them. They scraped the raw data from the study and started selling a $5 test. The pitch was, you upload your raw 23andMe data file to our app, and our algorithm will give you a gay score.
That is unbelievably dangerous.
It is deeply dangerous on an individual level. Imagine a vulnerable teenager living in a deeply conservative family or a country where homosexuality is criminalized, and they get a high score on this app. And politically, it's dangerous because it violently reinforces the destiny myth. It tells the public that sexual orientation is just a simple biological switch you can measure on a phone, or conversely, a genetic defect that can be screened for and eliminated.
And it's not just $5 apps. The book talks about a company called Heliospect. They were targeting high net worth individuals, charging up to $50,000 to screen their IVF embryos specifically for IQ.
$50,000. And the wild part is, they were explicitly promising a gain of up to 6 IQ points for the selected embryo.
Can they actually deliver that, scientifically speaking?
Scientifically, it's highly dubious. The error bars on those predictions, especially for something as environmentally mediated as IQ, are massive. You could pick the high IQ embryo and still have a totally average kid. But ethically, it's a disaster. Because what they're really selling is the hope of biological superiority. They are monetizing the conceptual asset.
It really seems like all these direct-to-consumer companies are just exploiting the fact that the general public doesn't understand the two acids. They sell us the literal acid, the swab, the test, the raw data, by directly appealing to the conceptual acid, the myth that our genes are our absolute fate.
That is exactly their business model. They sell certainty in a biological system that is inherently probabilistic.
So we are coming to the end of our deep dive today. We've covered a massive amount of ground. The Bloomers experiment, the Biggs twins, the parallel universes of counterfactuals, the Gattaca-style IVF clinics, and these incredibly sketchy phone apps. What is the ultimate takeaway from Trejo and Marchenko here?
The primary takeaway is that we cannot simply uninvent the literal acid. The genomic technology is already here. The costs of sequencing DNA are dropping to near zero. We're going to be able to read and predict incredibly complex things from our genomes. That is a given.
So the solution then has to be dealing with the conceptual acid.
Precisely. We have to completely change the story we tell ourselves about DNA. We have to educate people exactly like we're trying to do right now to understand that a polygenic score is not a prophecy written in stone. It is merely a statistical probability, and it is entirely contingent on the environment the person lives in.
And we desperately need that adversarial collaboration they modeled in the book. We need the Sam Trejos of the world to build the data tools, but we absolutely need the Daphne Marchenkos sitting right next to them to write the ethical warning labels.
Because if we only listen to the quantitative folks, the Sams, we end up with a blind, tech-driven society that ignores the brutal history of racism and actively widens inequality. But if we only listen to the qualitative folks, the Daphnes, we might ban genetic technologies that could genuinely eliminate terrible diseases or help struggling kids get early interventions. We need the friction between the two.
The authors end the book with a provocation, and I want to leave the listener with it today, because it's really a question of definition.
What is a good human?
Right. If we actually have the power to select, to mathematically shape the biology of the next generation, who gets to define what good means? Is good just being smarter on a standardized test? Is good just being taller? Is good having a lighter skin tone because society rewards that?
And if we don't actively regulate this market, if we just let the loophole economy and private companies decide, then the definition of a good human will simply become whatever the richest people in society can afford to buy.
And that is a world where the Bloomers experiment from 1960 just never ends. The privileged get the Bloomer label before they're even born. The label makes them bloom because of the environment they are in. And they spend their whole lives telling themselves it was just their superior biology all along.
But now, hopefully, we actually know the trick. We know how the two acids interact. And ideally, that means we can still change the outcome.
Such a fascinating conversation. Thanks for diving deep with us today.
Always a pleasure. See you next time.